Okay, so with rational functions, there can also be a slant asymptote, which basically means it's not a horizontal line or a vertical line, and it's a line that has a slope. And to find out where that is, we're going to do that now. First, it only has a slant asymptote if the degree in the numerator is exactly one more than the degree in the denominator. And so to find the slant asymptote, you divide the numerator by the denominator, and you're left with a linear, mx plus b, with the remainder over the denominator. This line, y equals mx plus b, is the slant asymptote. You don't include the remainder. That won't make a difference. It's just the y equals mx plus b part. So note, as the x approaches negative infinity or as the x approaches positive infinity, it will approach the y value, or the function will approach this line mx plus b. Okay, so here my numerator is 1 degree more than my denominator, so I'm going to divide. Make sure, remember, I have that 0x term, and I have to use long division here. But if you're able to use synthetic division, you can. Okay? So this becomes, I'm going to pause it and go ahead and work it out. So you pause it, work it out, and then you can check with me. Okay, so when I divide, I get 4x plus 5 plus x minus 2 over x squared minus x plus 1. Notice my sign changes I used in green, if you're having issues how I got that. But all I'm really concerned with is this linear part. And that is my slant asymptote. Is y equals 4x plus 5. And what that means is you have that line on the graph, y equals 4x plus 5, and the rational function will a lot of times come in like this and do something like that and go towards that asymptote, towards that slant asymptote, and it has that little slant to it. So go ahead and try to find the slant asymptote in this one. And we'll go over the answer first thing in class. Remind me. I got a joke for you. Alright, what do you call an elephant in a phone booth? I know you love these elephant ones, right? Stuck. Ah!